welcome back. The next topic, photogrammetry, photorealistic 3D environments and humans in virtual reality. Welcome, Mr. Zacker from Anotherworld Virtual Reality.
Hello.
Thank you.
Hi. My name is Max Zacker. I'm from Anotherworld VR. We are a Berlin-based virtual reality content production studio. And we specialize in the cohesion of cinema and virtual reality. So what does that mean? One of our projects that we're showing here today in sneak peek form is a horror film based in 1970s East Germany. It's in Brandenburg, about a little boy that befriends a kobold, but not a friendly or cute kobold that you might see from a Disney film, but a evil, horrible kobold. And the story from the film continues in interactive virtual reality. So what we did is we digitized the set environment where the film took place, the locations and all the surroundings using photogrammetry, which you may know is a digitalization technique for capturing real-world objects or environments through scanning with photography. So what you're seeing is the closest form of realism that you can get in a video game to match a cinematic aesthetic. And on top of that, it's interactive. So the people that are playing are able to physically move a flashlight around in their hand or touch objects, pick up things, solve clues, gather riddles, to try and find out what happened to this little boy. This is a creative project that we're pushing as our first film and VR piece, but it's an example of how this technology can be applied for creating ultra-realistic graphics and simulations in virtual reality. So, why is that relevant to here? Because digitalization is a topic that's hitting industry at a massive rate. What we as a company do is we try to enable full immersion, which means the feeling of actually being in another place, being able to interact with objects and feel like you're somewhere else. Intuitive interactions means you can actually touch things. You can physically feel like you're touching something else. And cinematic realism is because we come from a movie-making background, so we have a high expectations for what can be considered realistic in virtual reality. But I want to talk about the technique a little bit. What we're doing here is we're using photogrammetry, which is a process of taking many, many hundreds, sometimes thousands of photos and running it through software that generates a point cloud and then a mesh. A 3D textured mesh, which by nature already looks real because it comes from reality. Here's an example. One of these pictures is a game engine environment that was scanned in photogrammetry. The other one is filmed on a smartphone. Which do you think is real? On the left is the exact same scene captured in digital form. And oops, 1 second. Let's go back there. The other one was just filmed on a smartphone. So we have the technology to be able to create 3D environments as realistically as we can film them from a camera and make them a place that you can visit and explore for yourself. There are industrial applications for this too. One of our pilot projects, which we're testing right now, oops, sorry. Play again. I want to show you guys that video, 1 sec. So actually, not very good at the clicker. How do I play the slide? All right, 1 second. Okay, here we go. So there's a drone flying from the air, and what it's doing is it's taking aerial photography. This is very common in aerial surveying for topography, but also cameras on the ground, which are taking detailed photos, and these can be connected through software to create a realistic environment by calculating the distances between the camera positions and making that information that can be turned into a 3D model. So you may see some companies with scanners around here. You may see certain LiDAR techniques. This is done completely with photographs. There's no lasers involved whatsoever. And again, on the left-hand side is the game version. On the right is the filmed. An industrial application that we've been testing is, this is for a German railway company. The idea is to capture real-world environments of construction sites from the air, thereby not having to interfere with them. So, you know, there's trains running here, there's electricity, it's dangerous to walk around on track. We can fly with a drone, take photos of the environment, and then run it through a magic piece of software that creates a rig. A 3D textured mesh, which can now be used as a surveying, measuring, planning, and construction tool. So you see here, this is a rail engineer who is measuring the distance between the top of a rail piece and the side of the Schienenoberkante zu Bahnsteigkante, basically. So there are many applications for using this technique of photographing a real environment and making it a virtual tool. Just to recap, drones fly in the air, take aerial photography, give reference points, geo-coordinates, GPS, and can create a high level of realism and quite mathematical precision of where objects are in space. So good photogrammetry can achieve anywhere between 3 to 5 centimeters of realism. Great photogrammetry, and this depends on the skill of the operators, can go down to millimeter precision. We can go into the tiniest details and capture a place exactly how it is without interfering it and get a generated mesh and texture out to work with for a variety of applications. Here's an example of detailed photogrammetry. On the left is a result of a point cloud from a sarcophagus of an archaeological site. And on the right is the mesh. This was done with a smartphone, taking photos at high detail, lots of photos of this grave. And we have, for archaeological preservation, for a number of educational purposes, a realistic 3D model of that sarcophagus. And the magic software that I mentioned that does this is called Reality Capture by a company called CapturingReality.com. 2 of their representatives are right here. And I recommend you check it out because where previously this kind of technology was very difficult to achieve in a speedy sort of workflow where you would have to deliver to a client in a matter of days or weeks. This was impossible until recently, until this software made the process fast and efficient. So you can get these results within a day or 2 if you know how to use it. Okay. Here are some examples. I'm sorry, the screen it's a little bit dark, but here are some examples of where we used capturing reality, or Reality Capture is the name of the program, to create environments for Cobalt. These are, again, real locations that were digitized exactly as they are and then lit in a cinematic style. But what about humans? So I've talked a little bit about environments. Can we do this for humans too? Can we get realistic representations of our physiology, of the wrinkles and the special things that make every human individual? Can we get clothing with, how do you say, wrinkles or exact anatomy? Yes, we can. This is a case study that we did in cooperation with another company that's present here called BotSpot. They have a stand over there. And what we did is we applied, this is one of the actors from the film that we have as a 3D figure in the game. We applied special effects makeup and placed him inside something called a scan dome, which takes multiple pictures from different angles to create this raw 3D generated mesh. This is then cleaned up in a process called retopology to make it efficient for a games engine so that it can be played back at a lower poly count but a high texture resolution. And finally, the rigging and animation of so-called blend shapes, different facial expressions to create realistic speech, gestures, and human behavior. This is an example of the character's appearance in the game Cobalt, which you can also see over at the stand with BotSpot. So just to recap on that, real quick, back. This is the next step. 1 second. Danke. Doesn't seem to. All right. Give it a moment. One more. Nah. Okay. I'm going to let the video run again in case any of that wasn't a little. It's a lot of information that may not be clear. It's a real actor made to look old. He has to be 30 years older in the game than he is in real life. Scanned inside a 3D scan dome. These are the raw results. And then the hair and certain fine details and the face topology is cleaned up, prepared for a smooth performance in a games engine. And finally, the different facial expressions that can be captured by the scan dome are animated together. And one of the things that's interesting about BotSpot's scanner is not only just the quality that it can deliver, but the speed at which it can take different facial expressions. So you have to imagine, in order for me to speak the way I'm speaking right now, I have to perform a variety of gestures, like, and these have to be captured one after another at a rapid rate in order to make the animation work. All right, hopefully now, yes. So they are over at booth 2611. If you want to check this out and test out Cobalt and see what it feels like in virtual reality, please go and pay them a visit. And again, the scan dome can complete a scan of a human in a couple of seconds. They push a button and the photos are taken and then the data is there. Finally, how do we create movement? We connect the same character into something called a motion capture suit, which basically transfers that movement onto the 3D figure. And the performer can reenact the scene, move and talk how he would in a film, and we would transfer that data onto a 3D model that can be used in virtual reality. And where you can see that all coming together is in our VR experience called Cobalt, which is a horror piece, which, if you're brave enough to try, is also over at the BotSpot booth. Okay. Are there any questions about that? Thank you.
Thank you, Mr. Sacker. Are there any questions from the audience? Yes, sir.
So for the Cobalt experience, you mentioned that that is a VR experience.
Yes.
About to be tried out at the BotSpot booth.
A sneak peek. We can only show a tiny piece of it.
Okay.
But
is that going to be an experience that I can download onto my own Vive and try it at home?
Correct.
Okay. You mentioned like physical interactions where you can actually touch stuff. Is that possible?
What I mean in this instance is that you can see an object in VR. You can pick it up, and your hand controller kind of feels like that object. So like the flashlight that you hold in your hand is like a real flashlight. It behaves in the same way. So it feels realistic. In order to create haptic interaction, the kind that I actually have a glass standing here that I can see in VR, and I touch in the real world, you have to create the environment, obviously, where the glass is really standing there. But this is being done in the arcade space, and so like there are many places you can go, in Germany as well, where you can experience completely immersive environments where the walls are exactly like they are in VR, and the chair is where it should be, and you can have that level of immersion as well.
Thank you. Well, I got a question too regarding the precision of your capturing system. You showed us the short video of measuring the rail track.
Yeah.
Well, at what value do you, what precision do you
It depends entirely on the skill of the person conducting the photogrammetry. The software can do as precise as the pictures that you give it.
Okay.
So if you take many photos and you know at what angles to take those photos, and you make sure to get detailed pictures as well, you can have up to nanometer precision. If you don't have so much experience and you just take a certain amount of photos, it can be centimeters. It very much depends on the person conducting the scan, so to speak.
Thank you. Very interesting. Any
Anyone
more
else?
questions? Well, then, thank you, Mr. Sacker, for your
Okay, thank you.
presentation. Very interesting. I wish you good luck.